Okay, good morning. This is the Gardener community meeting. Today we have two topics on the agenda. It seems Arash is still not in the call, so I would propose that we start with Martin's topic about the Gardener Enhancement Proposal 8, SNI Passthrough Proxy for kube-apiserver.
Okay,
Martin?
yeah, can you hear me?
Yes.
Okay, let me share my screen. Okay. Just a second. Okay, so I guess you can see my screen.
Yes.
Okay, so this talk is about, as Matthias mentioned, about the enhancement proposal for more or less reducing the amount of load balancers that you need when you create a Kubernetes cluster. So what we do today, so for every single Kubernetes shoot cluster that you create, we create a dedicated load balancer. Pretty much, it's very easy. We use a cluster of type load balancer, and then Kubernetes does the rest. However, this approach has several benefits, several downfalls, and one of those is first it costs money. For example, on AWS, a classic load balancer can cost at least $17 per month. You also have quota problems, depending on the cloud provider. You might hit into problems, especially with the amount of load balancers, and also it takes some time until it's provisioned and also deprovisioned. So, how one problem would be to pretty much limit the load balancers to one for every single seed cluster. So every single seed cluster can have should have one balancer, and this load balancer can dynamically choose which shoot cluster it can run. It can send traffic to. So, however, there are several challenges with this. The first thing is that this load balancer should be at least level 7, because you can also you should add like certificate to it. And unfortunately, not all providers support this. It's a vendor lock-in, and it's not easily done by Kubernetes service. And finally, you also don't want to terminate the TOS connection at the load balancer, as the client can often use TOS client authentication. So going with the cloud providers with this it's very challenging, and it should not be applicable for our use case. And this is where the SNI, or server name indication, comes. So this is an extension of the TOS, and indicate, and inside of the TOS hello, you actually, the client can specify to which cluster, to which host or server it wants to connect to. And there is a proxy or a load balancer in front of it, which checks this server hello, and this server name, and then sends the IP address sends the traffic to the correct cluster. So in this case, we are accessing food.com, and then the server will serve food.com, or if we access bus.com, the server will return bus.com. So going one step forward, in order to solve this thing cloud agnostically, we simply need a TCP load balancer, which every single cloud provider already has. And after this, we need to put a special proxy, or SNI aware proxy, which will do, which will check the server name which the client sends, and then it's going to send it to the correct shoot cluster. So pretty much in the first case, we're accessing shoot 1, and then the proxy knows that where the traffic needs to go to, and then it sends all the traffic to the shoot 1. If it requests shoot 2, the proxy will send all the traffic to shoot to. The important thing here is we do the proxy does not do any TOS termination. It simply passes the TCP stream to the correct cluster, and it only inspects this server name in order to determine where to send traffic to. Okay. However, there is one fundamental issue with SNI, and that is that clients must request which cluster, which server they want to access. This is working very pretty much all the time if you have a kube control, because inside of it you already have the server name of the IPS of the Kubernetes cluster that you want to access. However, when you have cluster which is running inside of the pods on your nodes as a workload, normally they're using the automatic API discovery, and this means that pods are talking on or trying to access the Kubernetes API server via the cluster IP address of the master service in the default namespace called Kubernetes. And normally in this case, it's 192.168.0.1. And in this case, the server name is not set because you're actually trying to initiate the TOS connection to an IP address. And therefore, the SNI proxy won't work. So there is a workaround. Pretty much you can have this Kubernetes service, the master service, to be of type of external name. However, this currently is not supported by kubelet, and kubelet won't inject this environment variable which is needed for automatic discovery. So I've opened a cap for it. Unfortunately, I think it will be currently not implemented, and hopefully there is another proposal from some other contributor to change the way the discovery works, and hopefully it's going to be adopted. And even if we solve this problem and then finally you can use the external name, you still have a problem. And this problem is that clients inside of the cluster can actually use the host names, the service host names, to talk to the Kubernetes API server. So in this case, Kubernetes default service, and so. And those are the same, pretty much. So when you open a when you try to open the connection, the SNI or the server name would be the same for all clusters. So the proxy cannot actually distinguish between any of them, and you have again problem. So how to fix those problems? Well, you need to find some uniqueness, and this uniqueness in our current architecture is the cluster IP of the Kubernetes API server inside of the seed cluster. So this is very unique because services Kubernetes have a unique IP address. So what we do is we start the kube-api server with advertised address pointing to this IP address. Then on every single node inside of the shoot cluster, we create some proxy which listens on this IP address at port 443. And then this proxy sends traffic to the seed load balancer via the proxy protocol. And the proxy protocol is very white light. It simply prepends a header when you create a connection with the source, client IP, and port, and then the destination IP and port. And then on the seed side, there is the proxy which we mentioned previously. It listens for this protocol, and then it uses the destination IP address, which would point to the cluster to the API server's cluster IP, and then it will send TCP traffic to it. So to put it more graphically, So intent user will request, for example, Kubernetes default host, and which would resolve to the cluster IP, which is 192.168.0.1, and kube-proxy will redirect this traffic to 10.3.2.1. On the same node, we have a proxy which will listen on this IP address, and then using the proxy protocol, it's going to send the destination IP to this address. It's going to send it to the seed load balancer, which would simply send it as a TCP stream to the proxy, which would listen for this protocol. And then finally, it's going to see that, okay, the client is requesting 10.03.1, and this would in fact point to this cluster here. And for example, now we have a demo. So before this, any questions? Just at the theoretical part. Okay. Okay. So what do we have? We have a seed cluster. We have 2 shoots inside of it, and now let's go into the first shoot here. And here we have the standard Kubernetes API server. Everything is the same pretty much. And we get the services in this case, the Kubernetes API server. And as you can see, currently, this API server is of type cluster IP, and it has this IP address here. So if we get the pod for the kube API server, I think this one. Yep. And then we see that, let me just zoom it a bit. We see that the API server is started with this advertised address, and this advertised address points to the cluster, to the cluster IP. So at the end, the shoot cluster would actually get the endpoints Kubernetes in the default system, in the default namespace to be this one. And we also have the DNS entries here, and this DNS entries actually point. So NS lookup. So if you look at this one, it actually points to this IP address. Well, the current implementation is that we use Istio or Pilot. So inside of the Istio namespace, we have several pods, which is the Istio Ingress Gateway, which is our main target. And here we have the services, and then we see that this IP address here is actually the same as the Istio Ingress Gateway that we have created. So pretty much all the traffics for this API server here goes to this IP address. And how we actually do this entire thing in Istio, you have like gateways, and we have virtual services. So we have a gateway, and if you look at this gateway, we see that this gateway actually is listening via SNI. It's passing communication it's doing TOS pass-through, and it's listening for those hosts which we have before. Okay, and then we also have another interesting thing called virtual service. So this virtual service again listens on this gateway. It actually checks the SNI connection that the end users are going to send it, and then it points to the correct destination in the seed cluster. So for every single namespace that we for every shoot cluster we create one of those virtual service and then gateway resources. And now I can just do curl and then simply access, for example, this one. Sorry, HTTPS for my machine. -k, and right now I'm unauthorized, so I'm able to access this cluster. So what we also have is we also have another shoot cluster again, and inside of this namespace we get that the kube-apiserver it's again of type cluster IP, and here we also have virtual service, and then we also have the gateway. So right now we have two shoot clusters, and let's see what we have for every single one of those. So in the kube system namespace, we actually create this API server proxy, and as you can see, everything is running. And this API server proxy is the component which is listening for the proxy protocol. The current implementation is that it uses Nginx, and the configuration get config map. What was called config map code? Oops. Sorry. Yep, and this is the config map. And currently, as you can see, it listens on this IP address of the service in which is created in the seed cluster. It also sends traffic to the correct upstream, and then it simply listens, and then it simply uses the proxy protocol to send traffic to the seed cluster. So when we go there on this machine, we can more or less, we have some pods in the default namespace. As you can see, an Alpine pod, so we can exec into it. And then we can do a curl -k to the HTTPS, Kubernetes, default, for example. And then we need to install curl. Okay.
There's a typo.
Yeah. Kubernetes. Yep. And as you can see, the pod can actually talk to the correct API server. It can talk to the API server. It's not authorized currently. So how does this entire thing work? So we have a privilege pod which is running on one of the nodes. Exec here, and then here we can see that on the loopback interface, we have this IP address here, and it's simply created as an address on this interface, and then the Nginx is starting and it's running on it. So again, it is the same thing for the other shoot. So in this case, so this is the shoot cluster, and then we have here in the kube system only because only one, not only one pod, and this config map again it's listening on some other IP address. So this is the shoot cluster 2, which is listening on the 192 at the end, and the previous one is listening on 212 at the end. So pretty much this is more or less the demo. Any questions about the demo?
Hi, Martin, this is Vlad.
Yeah?
Very nice. You finally got it around working. I have a question. I posted a link. There's a caps around the network proxy.
Is the other way around.
Yeah.
No.
The ups.
Yeah, but
Okay.
but this is for the API server to the worker nodes.
Okay.
We wanted the other way
is
around.
That a functionality? Is that a functionality one could also reuse? I think I know that in the initial discussion it was kind of both ways. I thought, but I might have misunderstood.
I mean, so the problem, currently it's not needed in our use case because first you don't want to, for example, put the already existing TCP connection and to encrypt it again, because you with the proxy protocol you don't do any tunneling or encryption or anything. It simply sends traffic to some endpoint pretty much.
Mm-hmm.
And because the nodes can already talk to the shoot cluster to their API servers, so this is not needed. However, for the other way around, where you might not have connectivity at all, it's actually a must that you open like a tunnel or some other open TCP connection from the nodes pretty much.
Okay.
And those completely separate things. Later on, hopefully we'll be able to get rid of this load balancer in the, sorry.
Yeah, the proxy itself, right?
No, no, we want to also get rid of this load balancer and this load balancer for the VPN, and to invert the traffic as well.
Mm-hmm.
But again, for this use case, when talking from the nodes to the cluster, the proxy protocol is the lightest, is the lightweightest implementation pretty much, without any tunneling, any encapsulation, or anything like this.
Now for the proxy server itself, the kube-api proxy server, what was named? I forgot. Couldn't we use Istio for that as well? I mean,
no, because it cannot currently it cannot send traffic to upstream clusters via the proxy protocol. It's not supported by Envoy, so Envoy cannot use the proxy protocol to send traffic. It can only listen for the proxy protocol.
Isn't there an Istio egress which you can?
No.
Okay.
No. I mean, Istio cannot. Okay, the Envoy component cannot send traffic using the proxy protocol. It cannot, for example, get the TCP connection and then append the header. It simply does not have this functionality yet.
Mm-hmm. Okay.
Okay.
Thank you.
Any more questions? Okay, let me just finish with final touches. So, oops. Okay, so this is a demo. In the slides which I will share, after presentation, you actually see there are some interesting links which you can read. So we have the sidecar which is running there. We have the SNI, and then finally the proxy protocol specification, which you can more or less have a look into it. So I think this is from my side. If there are any more questions. Okay, it seems not. So
thanks, Martin.
What is the plan forward? Are we still needing to test, or?
We need to tune some things. So we need to tune to tune the different components. So the good thing is, and then do some scale tests pretty much. The good thing in this case is that the Istio I mean, like the envoy, is going to, in most cases, act as a simple TCP load balancer. So, and it will be pretty much okay in this regards, because it actually won't take any. It's taking almost zero resources, as you can see, for like those two clusters that are running. There is no running workload on it, but it's pretty much good indication of what we are looking at, just two clusters.
And we're reducing the Istio control plane to the minimum set, or waiting for the Istio to become a macro service.
I mean, right now we are again deploying. So the current implementation which I have running, you can actually have Istio installed by Gardener, and in this case we will install only the Istio pilot and then the Istio ingress gateway. And this is the only two components that we require pretty much. Or you can have it installed by yourselves. Okay. So if you already have it running. And yeah, so we need only those two things pretty much in order to run. And some other things which are probably interesting to those of you who are get envoy proxy. So we also create some filters which are just pretty much allows us to which pretty much enhance the filter chain, and we simply specify, and we specify that for example, if you request a destination address for this one, it's going to be sent to the correct API server. So this is the only thing that we also add currently, as well as a pretty much hack, because it's not setting like those IP address prefixes as a destination. Okay.
Thanks, Martin. I got an email from Arash that he couldn't make it today, so I will reschedule this topic for another meeting. So I think if there are no other topics, any other topics you want to discuss? If not, this is the end of today's meeting. See you next time. Bye.
Bye and thanks.